All right. So I'm going to go ahead and go through the, 3B section of the final review packet. On the screen here, I have like the summary sheet of how we find things like the horizontal asymptote, vertical asymptote, intercept, all that good stuff. If you don't have it on your note card, I would pause the video and copy this down. So this is how we find horizontal asymptote. And then for the rest of them, I use this example to find the rest of the things you need to be able to find. So again, like I said, pause the video, copy these down. All right, so I will be like referencing this as we go through it. All right, so if we look here, it says, so we're starting out with this guy. We got to find all this stuff, right? So if we look, finding the horizontal asymptote, we have to look at the degree of the numerator versus the degree of the denominator. All right. The degree of my numerator here is 3. The degree of my denominator is 2. So it's bigger on top, which means that I actually do not have a horizontal asymptote. All right. Then after finding my horizontal asymptote, I got to go find my y-intercepts here, right? So to find my y-intercept, I go and I plug in 0 for x. So I do 0 cubed minus 5 times 0 squared all over 0 squared plus 0 minus 6. I end up with 0 over negative 6, which is 0. So my y-intercept here is 0, comma 0. Next, I'm going to go ahead and factor this. So let's see, on top here, I get x squared times x minus 5. And then in the denominator, I get x plus 3 and x minus 2. All right. So then from there, I can, let's see. Yes. All right. So then from there, I have to look and see, okay, does anything cancel? Because that gives me a whole. In this case, nothing cancels, so I actually have no holes, which I guess it isn't asking for that anyways. All right, and then we can go ahead and just go down the line here to find the x-intercepts. I take the numerator and set it equal to 0, so I'm going to say x squared is equal to 0, which gives me that x equals 0, and then x minus 5 equals 0, which gives me that x equals 5. So for my x-intercepts, I get 0, 0, and I get 5, 0. Then to find my vertical asymptotes, to find those, I take the denominator and set it equal to 0. So I do x plus 3 equals 0, x minus 2 equals 0. So I get that x is equal to negative 3 and x is equal to positive 2. All right. Now, finding the domain on these, all you do is you take the denominator before you simplify anything and set it equal to 0, and that gives you what x cannot be. So like our domain here would be that x cannot be negative 3 and x cannot be equal to 2. Don't worry about doing the range for these problems. All right, just focus on knowing how to do the domain.
You don't have to do the range?
I just said that, yep. All right. All right, so now we look here. First, let's look at the horizontal asymptote. So for finding the horizontal asymptote, we know that we have to look at the degrees. Well, the degrees are both 2, so we look at the leading coefficients. So then we just take their ratio. So I got a 4 and 2. 4 divided by 2 gives me 2. So my horizontal asymptote is going to be y equals 2. Then I'm going to go and find my y-intercept. So I do 4 times 0 squared minus 1 all over 2 times 0 squared minus 18, which gives me negative 1 over negative 18, which gives me 1/18. So my y-intercept is 0, comma 1/18. Next, I need to go and factor this. So let's see. On the top, I have a difference of squares. So I get 2x plus 1. Whoops. 2x minus 1. And then in the denominator, we take out a GCF of 2, and I get x squared minus 9, which then I got a difference of squares again. So I get x plus 3, x minus 3. All right. So I look, and I'm like, okay, do I have any holes? There aren't anything that, there's nothing that cancels out here, so I don't have any holes. So now to find my x-intercepts, I take my numerator, and I set it equal to 0. So I'm going to say 2x plus 1 equals 0. 2x minus 1 equals 0. And when I solve this, I get that x is equal to negative 1/2 and x is equal to positive 1/2. So my x-intercepts are going to be negative 1/2 comma 0, and 1/2, comma 0. Then I go ahead and find my vertical asymptotes. I set my denominator equal to 0. Now, in this case, when I have literally just a 2, I cannot make 2 equal to 0, so it doesn't help me at all. If I had like 2x, I could set that equal to 0 and solve, but I can't solve that. So here I get that x is equal to -3, and I get that x is equal to +3. So those are my vertical asymptotes. And then to find my domain, again, I just take my unsimplified denominator, set it equal to 0. I get that x cannot be equal to 3 and x cannot be equal to -3. Now, I know this like feels like counterintuitive, but the vertical asymptote itself, like this is like an equation of a line, right? So that like describes the vertical asymptote. When you're actually graphing, right, you're not allowed to plug in x is equal to 3 because there's an asymptote there. All right, that's why the domain is what it is. And again, we can ignore the range there. All right, let's see. So for this next one here, let's go through. First, we look at our horizontal asymptote. The degree of my numerator is 0. The degree of my denominator is 1, so it's bigger on the bottom. So I'm going to do y equals 0. Now, at this point, normally you would factor, but there really is nothing to factor here. So we go ahead. We can find our x-intercepts by taking the numerator and setting it equal to 0. Well, can I make -4 equal to 0? I cannot, right? It's just a number. So I actually don't have any x-intercepts. It doesn't even ask for that, I guess, but we would say no x-intercepts here. And then to find the vertical asymptotes, we set the denominator equal to 0. So I get that x is equal to 5. For my domain, it's just that x cannot be equal to 5, and don't worry about the range. All right, so in terms of graphing this, we know that we have a vertical, oh no, we don't, sorry. We have a horizontal asymptote here at, well, I made that real big, y equals 0. And then we have a vertical asymptote at 5. Also, I guess we should have went and found the y-intercept, right? Even though it didn't ask for it. If we're graphing, it's not that hard to find the y-intercept. So you plug in 0 for x, and I get -4 over -5, which gives me 4/5. So I can go and plot that as well. So 4/5 would be like right about here. All right. So now for the shape of the graph, you guys are going to have Desmos on the final, so you might as well just go and use Desmos. So you can go and type this in. We get -4 divided by x minus 5. And you guys from there can like see the shape of the graph. Of course, you could always check your y-intercept to make sure that you calculated it correctly. Additionally, you can even plot your asymptotes to like make sure that it matches your graph, right? So like if I do y equals 0, you can see that that matches the shape of my graph, and x equals 5. That also matches the shape of my graph, right? So I can go ahead and draw in the shape of my graph here. All right.
You have to do the page through that.
Do you have to what?
You know the page through that.
The asymptotes, yes. I don't know why I made them so dramatically big, but whatever. All right, let's see. Okay. This next one here, let's see. We have our horizontal asymptote. We look at the numerator versus the denominator. It's still y equals 0. All this, oh, actually, you know what? Never mind. This one shifts it up. So actually, let me take that back. For this one, honestly, what I would recommend doing, because we did not cover these extensively. You know what? Let me see. Give me a second. Yeah, I would not stress out about this one. Don't worry. We didn't do a ton of these, so don't worry about 46. All right. Oh, I have to stop the recording. How do I stop it?